Hello, everybody, and kia ora. In today's webinar, we will talk about the research undertaken to include updates for sustainability in the 4 parts of the Austroads Guide to Road Tunnels. We have 200 people registered for today's session. Welcome to you all, and thanks for joining us. My name is Ekaterina. I'm a communications officer at Austroads, and I will be moderating today's session together with one of our presenters, Georgia O'Connor. Georgia will moderate the Q&A at the end of the webinar. First of all, I would like to acknowledge the Australian Aboriginal and Torres Strait Islander people as the custodians of the land from which we are broadcasting today. I pay my respect to all this past, present, and emerging. I also acknowledge the Treaty of Waitangi and Maori as the original people of New Zealand. A little bit about Austroads. We are the collective of Australasian transport and traffic agencies, and our focus is to support our member organizations to deliver an improved road transport network. The project that we are focusing on today was delivered under the Transport Infrastructure Program, which is managed by ROSGAPI. A bit of housekeeping. So our presenters will speak for 40 minutes, and then we will have a Q&A session for about 15 minutes. The slides and the report can be downloaded from the handout section of your sidebar, which you will find on the right-hand side of your screen. To send us your questions, please use the question icon on your sidebar. If your question relates to any particular slide, include the number of that slide in your message to help us answer your question as best as we can. Also, let us know if you have any technical problems, but just a quick tip: if you lose sound or your picture freezes, the issue is most likely with your internet connection. So leaving the session and rejoining again via your registration link usually helps. This session is being recorded, and we will let you know when the recording is published on our website. If you listen to podcasts, you can also find Austroads in your podcast app. So our presenters today, Georgia O'Connor, a senior professional leader in the environmental management portfolio of ARB's Sustainability and Material Performance team. Tony Peglas, a technical director at Aurecon with experience in the planning, design, contract documentation and construction supervision of tunnels, civil structures and major infrastructure transport projects. And Les Lewis, an independent consultant with over 50 years experience in road engineering and management. We will first hear from Georgia, who will introduce the team and provide an overview of the project. Then Tony and Les will talk about sustainability in road tunnels, covering some specific areas of sustainability practice. Georgia will conclude the presentation with the summary of key points, and then we will move to your questions. So welcome to our presenters, and over to you, Georgia. Here we go.
Thanks, Ekaterina. Good afternoon all, and thank you again for joining our webinar today. In this project, our Austroads project manager was Nigel Lloyd, Principal Structures Engineer in Transport Services at Waka Kotahi New Zealand Transport Agency. I was ARB's project leader for this project. Our quality manager was Dr. Richard Yeo, and Tony Peglas and Les Lewis were contributing authors and subject matter experts. Our project working group comprised of the members of the Austroads Road Tunnels Task Force, representing the state road agencies across Australia and New Zealand and various industry bodies as shown on the slide. So we're going to start off today's session with a brief overview of the project and the Austroads Guide to Road Tunnels. So the purpose of this project was to investigate the issues associated with managing the planning, design, construction, operations and maintenance of road tunnels in a sustainable manner across Australia and New Zealand. By updating the Austroads Guide to Road Tunnels, the project aimed to provide owners, operators, designers and those constructing road tunnels to consider and to address sustainability during the life cycle of the tunnel. This work considered current sustainability scopes of work in the delivery of road tunnels in Australia and New Zealand and internationally, the influence of sustainability across all life cycle phases of a road tunnel, the benefit of rating schemes, how sustainability could best be moved from its current status as a discrete technical discipline to a key component of work of each of the technical disciplines, and how best to provide this information as guidance material. So the 5 key deliverables of this project were a stakeholder workshop, a literature review report, a technical report summarising the research and updates to all 4 parts of the Guide to Road Tunnels, and this webinar. So at this stage, the technical report has been published on the Austroads website, and the 4 updated parts of the guide will be posted shortly. So the Austroads Guide to Road Tunnels provides guidance on the planning, design, operation and maintenance of road tunnels in Australia and New Zealand. The guide is designed to be used by engineers, tunnel operators and technical specialists in tunnel technology, proponents of road tunnel solutions, senior decision makers and regulators in the various jurisdictions associated with the construction of road tunnels. There are 4 parts to the guide. These are Part 1, Introduction to Road Tunnels, Part 2, Planning, Design and Commissioning, Part 3, Operations and Maintenance, and Part 4, Retrofitting Tunnels. So as described, this project aimed to investigate the issues associated with managing the planning, design, construction, operations and maintenance of road tunnels in a sustainable manner. And it aimed to provide guidance on how to consider and address sustainability during the life cycle of road tunnels. So in order to provide this guidance, extensive updates have been made throughout all 4 parts of the Guide to Road Tunnels based on the research which will be presented in today's session. So prior to this update, sustainability was only briefly mentioned in the guide. Today, we're going to be focusing on some of the key areas of research. Specific and extensive additional information is provided in the technical report, and the covers of the Guide to Road Tunnels are included down the side of each slide, which you will see there on the right-hand side, and will be shown in colour where the relevant sustainability information being presented is included in that part of the guide. So for example, part 2 of the guide will be highlighted when we're discussing issues of construction. In addition, there's a speech bubble included on the top of each slide, as shown in this slide here in red. So this bubble signifies the section of the technical report, which the content can be found in more detail. So as I've mentioned, at the heart of this project is the concept of sustainability. It's a complex and evolving subject whose definition may vary from country to country, from industry to industry, and occasionally from time to time. So defining sustainability correctly in this project ensured that the updates we were able to provide in the guide were fit for purpose on the aspects of sustainability that truly matter for road tunnels across Australia and New Zealand. So this section of the webinar will start by providing an overview of the selected definitions for sustainability in this project. So as a general definition, Infrastructure Australia defines sustainability as meeting the needs of the present without compromising the needs of the future. In the context of infrastructure development, ISCA points to the need to follow design, construction and operation principles that will support meeting sustainability goals. Finally, in the report Road Tunnel Operations First Steps Towards a Sustainable Approach, PIARC recommends the development of sustainable tunnels to focus on 3 pillars of sustainability. These relate to economic, environmental and social outcomes. For this project, we identified and developed updates to the Guide to Road Tunnels by referencing this definition of PIARC's, as we felt it was the sustainability definition the most closely aligned with the scope of the guide. So as I mentioned, PIARC identifies 3 pillars of sustainability as shown in this image, which are sustainable economy, social and environmental outcomes. However, these pillars, they can't be seen to be independent. All the pillars do need to be supported in order to consider a tunnel truly sustainable, but in reality, sustainability choices for a road tunnel are typically a compromise between a balance of the pillars, as is also shown in the diagram on the slide. So here we take a closer look at the 3 sustainability pillars recommended by PIARC for road tunnel development. So the economic pillar aims to promote the generation of wealth that leads to improved living standards. To meet this aim, considerations should be given to identifying the optimal solution and implementation option that can deliver the highest net economic benefits. The environmental pillar recognises the impact that a tunnel may have on the natural environment. Considerations here may be to mitigate environmental impacts, including the management of pollutants, the consumption of energy, and the efficient use of resources. The social pillar speaks to the impact on people and society, including health, housing, employment, and other focus areas. Specifically, noise impact, visual amenity, and accessibility are just some of the examples that road tunnels may have on their nearby communities. So I'm now going to pass over to Tony and Les, who will discuss how sustainability relates to a road tunnel. This will include the importance of sustainability, the effectiveness of sustainability rating systems and tools, the Sustainable Development Goals, and sustainability barriers. Over to you, Tony and Les.
Thanks, Georgia. So obviously, sustainability in general is important for many reasons, but put simply, it's not about what we should do for the environment, it's something that we must do in order to preserve our quality of life and all of the lives on the planet. It's particularly important for a road tunnel because tunnels are not that sustainable. Tunnels do have some sustainable benefits, such as having a long lifespan, typically around 100 years, and they also have limited impacts on the surface. But compared to a road at grade, a road tunnel has a substantially higher carbon footprint, both during its construction and during the continuous non-stop operation of its systems throughout its operating life. So some key points identified through the project were that where tunnels have a major impact on the natural environment, they are energy intensive in that they require large amounts of natural resources to construct. And then relating to this point, the construction process of tunnels demands a great amount of material such as cement and steel. So we always promote our projects with facts and figures like the project will use 25,000 concrete segments and 100,000 cubic meters of concrete and it'll be transported by 4,000 truck movements. And these sound impressive, but at the end of the day, these are not measures of benefits in terms of sustainability. Construction also requires energy intensive processes, which can have significant impacts on the site's environment and community. So for example, excavation and spoil disposal. And the operations and maintenance phase is where the majority of carbon is generated. So typically more than 60% of the total embodied and operations carbon is generated during the operations phase. So in summary, the negative impact on sustainability for a road tunnel is larger than the impact of a road at grade. And as the tunnels have a long lifespan of around 100 years, any investment into sustainability is going to have a long-lasting effect. Another common theme identified through the project was that the earlier a sustainability initiative is considered, such as in the design phase, the better chance it has to be fully coordinated and incorporated into the lifetime of the project. And it'll also be less costly to implement. So this isn't really a surprise and aligns with the systems engineering approach in the most recent guide update where focus is made on defining requirements early in the life cycle where costs and impacts are most efficiently managed. So during the planning and design phase, you have the most potential to impact on sustainability. And during construction, the focus typically shifts to minimizing energy consumption and waste and limiting impacts on the environment and community. And then once operating, it's mainly about optimizing and improving on what has been inherited from the design. Since tunnels are the energy intensive infrastructure using energy 24 hours a day, and they require continual maintenance and refurbishment and upgrades. Rating schemes, which are also known as rating systems, are benchmarking frameworks and tools for evaluating the sustainability performance of infrastructure developments. So the primary function of rating schemes is really two parts. It's to guide sustainability assessments and then also to guide the sustainability objectives of infrastructure projects. So this slide provides examples of the national and international tools which were investigated as part of the project, and they're summarized further in the technical report. And the image to the right of the slide shows the standard structure of a sustainability tool, which uses a category-based methodology with various criteria for assessment. So for infrastructure projects, there would be multiple criteria, including environmental, social, and economic criteria. So the update to the guide part 1 includes reference to the Infrastructure Sustainability Rating Tool by ISCA, which is the Infrastructure Sustainability Council of Australia, and also outlines the rating categories and criteria used. I'll now hand over to Les. Thanks, Les.
Thanks, Tony. The UN established 17 Sustainable Development Goals in 2021, and those 17 goals were examined in our research and those relevant to tunnel projects identified. Of the 17, the tunnel project may have some impact on about 8, and of those a significant direct impact on about 4. The numbers of those are listed on the slide. But which of these goals will be important for a particular project may depend on the specific goal set for the project. For example, if an important feature of the project is to provide significant employment opportunities, then Goal 8, which is promote sustained, inclusive and sustainable economic growth, full and productive employment and decent work for all, will come into play. Another goal which is affected is Goal 3, which is ensuring healthy lives and promote well-being for all at all ages. And that, as one of the performance indicators of that goal, is to, by 2030, halve the number of global deaths and injuries from road accidents. In all cases, the details of the performance indicators will provide insight into the degree to which a project will contribute to the specific goal. These goals were developed to measure the overall performance of a whole nation and are therefore blunt instruments when it comes to assessing the sustainability of an individual project. That does not mean they're not important, and projects should ensure that they are consistent with those goals, which will be achieved if the requirements of the ISCA rating scheme are met. 2 recent projects reported on their sustainability against these goals. The Eastlink Sustainability Report. The report covers many issues: technical, employment relations and policies, customer service, and others. Reports against quite a few of the UN goals as listed there, and the Westgate Tunnel project, which noted that those goals 8, 9, and 11 were relevant to their sustainability approach. However, a more effective tool for the assessment of the sustainability of a specific project is the ISCA rating scheme used by the WestConnex and the NorthConnex projects. Over to you, Tony.
Thanks, Les. So the project identified potential barriers to achieving good sustainability outcomes on tunnel projects. Now I'll give here a few examples. So the first is contractual requirements. So sustainability is often expressed in contract documents as one of many requirements to meet, but typically it's not given a significant priority. So when a potentially improved sustainability outcome conflicts with time or cost or risk, there's no incentive for sustainability to win. So an example of this was the Cross River Rail project in Brisbane, where the use of geopolymer concrete was considered. However, the additional cost meant that there was no incentive for the contractor to push for its use. So raising the priority of sustainability requires commitment and communication at the client level as part of procurement, and this message has been reinforced in the guide update. Rating systems can be taken advantage of by adopting unrealistic business as usual standards, and a mitigation for this is to specify the business as usual standards before the tender process, and some jurisdictions have already started to implement this. Approval of new materials. So to achieve sustainability in practice, new materials must be permitted, and if this isn't contemplated or allowed under current client materials specifications or Australian standards, then a contractor who would seek to use these would likely face a long and risky approval process, and at the end of the day, this may not be worth pursuing by the contractor, particularly in a competitive bid environment or a time-constrained delivery program. And incentives to use sustainable products. So the last point is a quote from a paper by Alan Thomas called Achieving Sustainability in Underground Construction Through Innovation. And basically it's noting that without some type of incentive or reward, suppliers are not going to be inclined to create more sustainable products, and contractors can't be expected to adopt them in competitive bids, particularly if, even though the product is more sustainable, it's more costly. So Les and I are now going to discuss some of the specific areas of sustainability which were investigated as part of the literature review. So this will include energy efficiency, sustainable materials, waste minimisation, transport, ventilation, environmental issues and heritage issues. Thanks, Liz.
Well, the most significant contribution to sustainability under the heading of environmental considerations is in energy efficiency. In terms of energy efficiency, major contributions to sustainability can be achieved in ventilation, which Tony will deal with later, lighting. The introduction of LED lighting allows the lighting level to be tailored to the ambient lighting conditions at the time of the year, time of day, and weather conditions outside the tunnel. Adaptive control technology with a luminance meter outside the tunnel portal can be used to achieve this, and significant energy savings can be achieved with that system. Further savings can be achieved by shade structures at the portals and by appropriate landscaping at the portals. These methods reduce the difference between the external and internal light level, with a consequent lowering of the artificial light required in the tunnel. Introducing sunlight directly into the transition zone also reduces the artificial lighting required, and light pipes have been used for that purpose. In the power supply function, the renewable sources of power, such as solar power, can reduce the demand by this function, since the power available throughout the day reflects the changing demand for lighting inside the tunnel. The smart meters provide the means of varying the power demand depending on the actual tunnel requirements, and that can be used in the ventilation, lighting and pumping applications. The PIARC report written there gives a comprehensive discussion of the contribution to sustainability of green paving solutions. It notes that sustainability must be incorporated into all phases of the life cycle of the pavement. The life cycle of the pavement can be divided into the following phases: pavement design, materials, construction, the use phase, which is maintenance preservation, end of life, which is the removal and or disposal, recycling and reuse of the pavement. Material selection in the design phase affects all subsequent phases of the pavement life, and therefore has a major effect on the sustainability of the pavement. And this requires consideration of the energy used in the production of the materials, the effect on energy use by the vehicles travelling on the pavement, that is the rolling resistance of the finished product, a reduction in lighting required by the use of light-coloured pavements, potential that deleterious effects on the environment related to the production of alternative materials, for example, additives used, rehabilitation options at the end of the life of the pavement, and pavement and deleterious effects of disposal of the materials at the end of life. Material selection should consider the whole of the life cycle of the pavement, with a view to minimising consumption of resources, energy usage and emissions associated with the different materials. Tony will now talk about other substantial material use.
So as part of the project review process, we found multiple references that identified sustainability practices that could be implemented in the construction phase of the project. And there are many examples of the use of sustainable materials in construction, and reducing the environmental impact of construction materials. So we all know cement and steel are energy-intensive materials and fundamental to construction, but their environmental impact can be reduced with the replacement of materials in the concrete and reducing the amount of steel usage. So for example, using macrosynthetic fibers in sprayed concrete linings instead of steel, cement replacement in concrete, and other material replacements such as recycled glass instead of sand. Waste minimisation is also important, and one specific example of this is the recycling or reuse of tunnel spoil, which can have significant sustainability benefits for a project, including environmental and economic aspects. Spoil reuse options are provided in the technical report, and these are ranked from most desirable, such as avoiding spoil generation and the reuse of spoil, through to least desirable, such as disposal as waste. The spoil consistency and properties will contribute to the options for spoil reuse, and these are influenced by the geology and the construction method. So for example, whether it's excavated by a TBM, a tunnel boring machine, or road header, or drill and blast. An example of a successful tunnel spoil reuse was the Legacy Way tunnel in Brisbane, shown on the photos here. This project recycled the spoil through the nearby Mount Cootha quarry and then reused it for various works on the project, including backfilling the tunnel invert. During construction, transport is a major player in carbon emissions. Construction sites could be suitable for the use of non-fossil fuel powered vehicles. As an example, hydrogen fuel cells have been trialled in the mining industry as part of pilot programs. And since transport is located within a confined area on site, refueling can be undertaken with a dedicated refueling station. Electric machinery is yet to be adopted at scale in construction, but it's starting to be deployed with increasing numbers. And just worth noting that the last few examples that I've mentioned are implemented in the construction phase, but they still need to be identified early in the planning and design phase in order to be successful. And they also require the client to structure the procurement of the project in such a way that sustainability is prioritised. Many road tunnels in Australia don't allow portal emissions, and typically this is set through the environmental consent conditions as part of the procurement of the project. And this is a significant constraint on the design of the tunnel ventilation system. So the ventilation system is required to extract the air in the tunnel by pulling it against the natural direction of traffic flow at the portals and then forcing it out of a ventilation outlet. And this requires operation of the system 24 hours a day with significant costs in terms of energy consumption. So this isn't a flexible solution and doesn't take into account the likely reduction in emissions from vehicles built in the future, such as electric vehicles. And also doesn't take into account the varying use of the tunnel through a given day or week. So for example, in the middle of the night, there probably are very limited vehicles using the tunnel. So a more energy efficient ventilation system is to implement a managed approach, which allows portal emissions at certain times, so long as air quality standards are met. And this is discussed further in the guide. And this approach was implemented successfully on the Waterview Tunnel in New Zealand and recently for some existing Australian road tunnels. Thanks, Liz.
Well, this slide shows the various environmental issues that have been considered and that have been addressed in all previous editions of the AGRT. The text in AGRT Part 2 has been enhanced in many of the sections to emphasise the sustainability aspect, particularly in respect to groundwater contamination. It can be said that achieving acceptable environmental outcomes is an inherent part of sustainability. In this context, preserving the ecology of an area is an important part of providing a sustainable solution for an infrastructure project. The construction and operation of a tunnel may alter the availability and quality of the surrounding natural environment as habitats for flora and fauna. Appropriate measures must be taken to minimise any environmental damage or ecological damage. Degradation of habitat can be measured by the size of the area affected, so on a time span of degradation that is irreversible or reversible, and the size of the fauna population that is removed due to the project. Population and number of flora and fauna species that are divided by the alignment of the tunnel provides a measure of the fragmentation of habitat. The number of species of animals whose living condition is affected by the environmental emissions, that's fumes, noise and water discharge, from the construction and operation of the tunnel provide a measure of the disturbance to fauna. These matters should be addressed or must be addressed in the planning, design, construction and operation of the tunnel. Consideration of heritage values is an essential component of providing an overall sustainable tunnel project. This has not been addressed in previous editions of the AGRT. Guidance on how to provide Indigenous heritage, Indigenous heritage is provided by references listed in the update. In addition, all states and territories have legislation requiring consideration of European heritage values, and tunnel projects must adhere to this legislation. And that's the extent of the comments we make in the AGRT. Over to you.
The section 4.4 of the technical report provides an example of a typical sustainability approach and considerations or initiatives that could be implemented for a road tunnel project. Now, we won't go into detail on this. There's a lot more detail in the technical report. I'd like to highlight some of the key points that have been identified for setting up a project for sustainability success in terms of achieving meaningful sustainability outcomes. These include clear commitment and leadership to deliver sustainability outcomes, identifying minimum sustainability requirements that are feasible and effective, and this requires consideration of the scale of the project as well as the project scope and design. Structuring contract requirements in such a way that the project team and client prioritise sustainability, and management of the project so that design and construction decisions consider sustainability outcomes. They apply suitable prioritisation and then integrate sustainability across all disciplines and phases of the project.
Thanks for that overview, Tony and Les. So, as we mentioned at the beginning of the webinar, the objective of this project was to embed the consideration of sustainability into all parts of the Guide to Road Tunnels. So, as you will have seen throughout today's session, we've undertaken extensive research into road tunnel sustainability, which is provided in the Sustainable Road Tunnels Technical Report and as part of updates to the Guide to Road Tunnels. And as I mentioned at the beginning of the webinar, the technical report has been published on the Austroads website and the updates will be coming shortly. So the key focus of the research has been that sustainability can only be achieved through a balance of the 3 pillars of sustainability as defined by PIARC and through specific actions through a range of individual elements of a road tunnel as presented in that specific content by Tony and Les. So the overall sustainability picture is presented up front in part 1 of the guide with a new section titled Sustainability. And this section is referred to throughout all other parts of the Guide to Road Tunnels. The individual elements and specific actions which have been detailed today and which are extensively provided in the technical report are dealt with where relevant throughout the guide parts. For example, lighting and ventilation is in part 2. As I mentioned, that was shown down the side of the slide on all of the sustainability content presented today. So this slide here shows the sections of all 4 parts of the Guide to Road Tunnels that have been updated as part of this project. As you can see, sustainability has now been deeply embedded into the Guide to Road Tunnels, with a wealth of updates into sections varying from tunnel design through to retrofitting and refurbishment. For a detailed summary of the updates to the Guide to Road Tunnels and to assist tunnel practitioners with navigating the updated guide, the technical report provides detailed tables summarising the updates. So we're now going to move into discussing some of your questions that we've received today. So I can see on my screen here that we have a few questions that have come through. So the first question we have here today is, what is Austroad's position on portal emissions and portal capture? EPA's enforce portal emissions capture, but this can come at a massive cost. I believe this question did come through before our slide on portal emissions, but Tony, was there anything else that you wanted to add here?
I guess the position is now that the guide has been updated to, I guess, recommend where it's appropriate that a managed portal emissions approach is a more sustainable outcome. And as mentioned, as long as air quality, environmental criteria are still met. And as I was saying, so Waterview Tunnel has implemented this quite successfully, and I understand there's existing Australian road tunnels that I guess being applied to change their requirements to fit that approach where appropriate.
Great, thanks for that, Tony. So our next question is that, given that ISCA is now ISC, will the report be updated to reflect the recent change in organisational name? We can go through and double check the report. I believe the majority of the references are towards ISC. It was just based on the time in which the research was undertaken. So our next question is that there is a recognised method of relating, is there a recognised method, of relating all of the sustainability goals back to dollar values? Just like, for example, accountants cost projects back to a net present value. This way, everyone can relate to a dollar value as an objective. So this question's noted that many of the goals can be quite subjective, so relating it back to cost would be beneficial. Les and Tony, did we have an opinion on this one here?
Well, I don't think all of them will be easily converted back to dollars. People can make some attempt at doing that. I'm not aware of any specific methodologies to achieve that. However, it's still quite valid to use subjective measures, particularly if you use it as in some sort of multi-criteria considerations, and you can come to quite reasonable conclusions as to which is the most sustainable and which is not.
Great, yeah. Thanks for that, Les. So our next question is regarding the barriers of sustainability. So over to you, Tony. It's, should the quality be included with time, cost and risk? If quality is not achieved at construction and maintenance activities are then higher than expected to carry out treatments and will require additional tunnel closures.
Yeah, look, quality is, I guess, a minimum requirement. So there's usually, there'll be project specifications which will outline what those minimum criteria are in terms of achieving quality. So it's correct. Sustainable. There's no other sort of criteria that should mean that quality is not achieved, basically.
So our next questions both are in regards to slide 28 and 29, which is around the sustainable materials. So the first one is chrome rubber asphalt permitted in road tunnels.
Sorry, what was that?
Chrome rubber asphalt.
I didn't quite catch what that was.
So the question was, is chrome rubber asphalt permitted in road tunnels?
Oh,
chrome rubber. I mean, I can partly answer that. Generally, pavements in road tunnels are CRCP, so continually reinforced concrete pavements. It's usually up to the jurisdiction in terms of allowing what type of pavement is in a road tunnel, but generally because they want to limit the amount of closures and they want a long design life, a concrete pavement is specified.
Yeah, that has significant benefits also in terms of the wearability of the pavement and any creation of particulate matter that might get into the atmosphere in the tunnel. Much better to have the concrete.
Okay, great. So our next question is, fly ash as a replacement for GB cement is business as usual in New South Wales. Why is this geopolymer cement better than fly ash replacement?
I don't know the answer to that.
So geopolymer concrete, so my understanding is made with a geopolymer binder instead of conventional Portland cement, and that's where the real that's where the benefit is. So the binder is as a reaction of aluminate and silicate materials with an activator. So waste products like fly ash and blast furnace slag, can be used with that activator. So this is really good from a sustainability point of view. Basically, the production of cement creates huge amounts of carbon emissions, and this is due to two main things. There's a chemical reaction when you heat limestone, which is a key material for the cement, which releases carbon dioxide, and also due to the energy required for the heating itself. So I think that's technically, I understand geopolymer concrete has quite a lot of is just as good as concrete and has other advantages as well, just in terms of high compressive strength, low creep and shrinkage, etc.
Thanks for that, Tony. So our next question is in relation to environmental impacts and groundwater. So the question is seeking some further information around water tables and pumping and whether this is considered in the technical report or updates to the guide.
There's a general discussion of groundwater contamination. I'm not recall that there was a large amount of specific details included, but it deals with the general principles of it.
All right, great. Thanks for that, Les. So our next question is on slide 29 on a similar topic. So for spoil reuse, what are some of the examples of reuse?
Yeah, so there are a number of options for reuse, which is effectively recycling the spoil, and the technical report provides some examples of these, and but this level of detail hasn't gone into the guide update itself. But firstly, the option is to avoid, or the first option is to avoid or reduce the amount of spoil generation. But for a tunnel, obviously, it's pretty hard to avoid generating spoil, but you can reduce by optimizing the tunnel cross section, as an example. And then in terms of reuse, there's reuse on the project, so you may be able to reuse it in fill embankments with only a short haulage distance away. You could reuse it for environmental works, which could be flood mitigation works or rehabilitation projects for natural vegetation, for example. And this may require hauling the spoil a longer distance to where the other projects may need the spoil. There's land restoration, so like land reclamation and remediation works. So filling disused facilities like an old quarry. So what was done on the NorthConnex project in Sydney, there was an old disused quarry near the project. So the tunnel spoil was used to partially fill that quarry, and then it could be turned into a recreational facility like a park. And then as mentioned, in the presentation, the least desirable is but sometimes necessary. The spoil may need to be disposed of as waste at an approved facility, particularly if the spoil was contaminated, for example.
Great, thanks, Tony. Our next question is, how do you recycle a tunnel at the end of its design life? So, for example, in 100 years' time, do you rebore it and recycle the concrete?
That's a good question.
I don't think, well, generally when you design something for 100 years to design life, you're pretty much designing it to be permanent. And I think with, appropriate maintenance, and you design for 100 years, then you're going to achieve an outcome that is a lot longer than the actual 100-year design life. I mean, as an example, there are tunnels up in the Toowoomba Range that are currently 150 years old and are working, are still fine. So I don't know. I guess we'll find out as we get closer to 100 years.
Well, I won't be around then.
Nah.
Yeah. No, I think what Tony says is right. Good maintenance will keep those materials going for a long time. And if it came to reboring or something like that, well, perhaps that would be a very, very difficult thing to do.
Great, thanks for that. So our next question is that you mentioned that tunnels have a higher carbon footprint than a road at grade. How do tunnels compare with other forms of major infrastructure?
Yeah, so look, I haven't seen such a comparison, but to guess, I'd say that because road tunnels for construction require such high energy intensive processes, but also mainly for operation. They have systems like the ventilation and lighting are the main two for energy use, as well as other systems. And these need to be operating 24 hours a day. So I say road tunnels would have a higher carbon footprint than almost all other forms of infrastructure, like roads and bridges, railway lines, if you were to compare them with an equivalent length. I'd even say they'd have a much higher carbon footprint than a building.
Perfect. All right, so our next question is around the updates for the guide. So the question is, which part of the guide shows the most substantial updates for sustainability?
Well, it'll be part one. Part one includes all of the major discussion of what a sustainability is about, the principles of it, how to apply it, and the other parts deal with the implementation of it. I put it that way. The second most updates occurred in part two, which one would expect, and that reflects the requirement to deal with this issue up front, as far up front as you possibly can. And by the time you get to operation and maintenance, there are things that can be done for sustainability, but the basic sustainability outcomes have already been determined because of the design and the completion of the project. Certainly, the long-term energy usage of electricity and so on to operate the tunnel, that can be minimised, of course, through that process. But the amount of updates in the individual parts are reflected in that. So the most is in part one, then in part two, and some in part three, and part four, of course, uses a lot of the information in the other volumes anyway.
Great, thanks for that, Les. So our next question is back on the topic of carbon emissions. And the question is, do we have any carbon positive road tunnels in Australia or New Zealand?
Hard to, I wouldn't have thought so.
I don't think so. Is a short answer.
I guess on that topic, are there any case study road tunnel projects of sustainability initiatives that are worth highlighting?
Hmm.
Well, I mean, I think we've already spoken about it, but the portal emissions and the managed ventilation approach is worth highlighting. The ventilation system is one of by far the highest energy use for an operating road tunnel. So I think the Waterview Tunnel project in Auckland was a great example of taking that approach, and it's a great sustainability outcome.
There have been quite a few examples of the building of shade structures at the portals to reduce the amount of artificial light required in the transition zones. Some European tunnels have used light pipes to introduce more light into the transition zone of tunnels. They're worth looking at. And in terms of light-coloured pavements, there's been a reasonable amount of work done on that. I don't know of any specific ones in Australia, but there are some in Italy at least that have used a light-coloured material to reduce the amount of light required in the tunnel.
I think there's been quite a few examples of lighting upgrades as well, particularly for the older tunnels, from the old, sort of high-pressure sodium and fluorescent lighting to LED lighting. There's been quite a few of the old tunnels in New Zealand, and I believe Eastlink did it quite recently too in the last couple of years.
Yeah,
Thanks,
LED
Tony.
lighting, very important.
So our last question is, has any study been conducted in using sustainable materials in road tunnels on the corrosive effects of aggressive waters towards concrete? So I guess this is back on our topic of replacement materials.
I'm not aware of any.
I'm not sure, Georgia.
That's okay. We can have a look into that one for you. So I'll now pass back over to Katerina and bring our question session to a close. Thanks everyone for your questions.
Thanks, everybody. Thanks, Georgia, Tony, and Liz, and our audience. Well, just a couple of slides to finish this session. We have a couple of webinars scheduled, and in those sessions, we will talk about some updates to Standards Australia for bitumen and related materials. And another session will be about multimodal incident management. So if you're interested in any of them, please register on the Australia's website. And as usual, after we close out today's session, a questionnaire will pop up on your screen. So please take a couple of minutes to send us your feedback. It really helps us to know what you liked or didn't like about the session, and whether you have any suggestions for our future webinars. And once again, today's session is being recorded, and we will let you know when the recording is published on our website. So thanks again, everyone. Stay well and safe, and enjoy the rest of your day. We will see you next time.